So this is FRQ 2026 question number 3. This is actually experimental setup to determine kinetic friction of surfaces which are in contact. So in this experiment, the student releases a block of unknown mass near the top of this curved ramp. So if you release it, its potential energy will decrease and its kinetic energy will increase. So when this block reaches here, it will be having maximum kinetic energy. And then there is horizontal frictional surface where we know that coefficient of kinetic friction is mu k. So this friction will now oppose motion of this block. So this will be the direction of friction force, and it will oppose the direction of motion of this block, and ultimately it will comes to rest. So final velocity will become zero. So by using this information or this observation, we have to find coefficient of kinetic friction mu k. We have to determine mu k. So in part A, they have asked indicate quantities that could be measured by a student that would allow them to determine mu k. So obviously, let this be height h and let this be stopping distance s. So I think we can measure this h and s to determine coefficient of kinetic friction. So for part A, definitely we can measure this h and s, which can help me or which can help us to determine mu k. And in part A, they have also asked a method to reduce experimental uncertainty for measured quantities. So obviously, you should have a fixed reference mark. From there only, you are expected to measure this height h. Further, you have to release that block from rest. That means its initial velocity should be zero. So make sure its initial velocity is zero. Make sure all the measurement are done from fifth. Make sure that all the measurements are done from fixed reference mark. So for stopping distance, this should be reference mark. For height, this should be a reference mark. And for same height, you have to conduct this experiment 2-3 times, and then we have to take average value of this s. So all this will ensure that experimental uncertainty associated with measured quantity is decreased. Now, coming on to part B, uh, we have already uh, we already know that while drawing a graph, we will use stopping distance and height from which that block has been released. So for part 2, I am using work energy theorem, which states that work done by all the forces will be equal to change in kinetic energy. And I will be using this to determine relation between S and H. So if you release it from here, while it moves down, definitely normal reaction will always be perpendicular to direction in which that block is moving. So if block is moving in this direction, this will be normal reaction. So work done by normal will always be zero because normal and displacement are perpendicular to each other, right? So this is initial point and this is final point. And we have another force that is mg. And what is displacement in the direction of force? It is h. So work done by mg will be equal to mgh. So we have written it here. So this is work done by mg. Work done by normal, you don't have to type. It will be nothing but zero. And then suppose that block is here now and it is moving towards right with velocity v. then friction force will be acting towards left. What will be value of friction force? Friction force which will be acting towards left will be equal to mu k into normal reaction, which will be equal to mg. So friction force is mu k mg. So this has been written here. This is mu k mg. And displacement is s. This is displacement s. But angle between force and displacement is 180 degree, and therefore work done will be negative. So we have indicated it here with negative sign. Once again, this block is moving towards right. That is, displacement is towards right, and friction force is acting towards left. So displacement is s, friction force is mu mg, and displacement is s. But since force is acting opposite to displacement, I have incorporated negative sign here. So solving this, we get s is equal to h by mu k. So definitely graph between s and h will be a straight line. If I take this to be h and this to be s, then graph between s and h will be straight line. So this will be straight line passing through origin. This will be angle theta. And what will be slope? Slope is nothing but tan theta. And from here I can say slope will be equal to 1 by mu k. So this tan theta will be equal to 1 by mu k. So, so if you can draw this graph, then by measuring this angle theta, we can find coefficient of kinetic friction. In part C and D of this question, different experiment was conducted in which a student releases a block from rest on a rough ram. So this is rough ram, and here block is released by a student. An angle of inclination of that rough ram is given to be theta, and d is the distance from photo gate from which block was released. So what is function of this photo gate? It is used to determine speed of block. So when block passes through this photo gate, its speed is recorded. And corresponding to this experiment, readings, that is distance d, corresponding to which velocity recorded by photo gate is given. And angle of inclination theta is given to be 30 degree. So now see what is asked. Okay, so this was the expression between velocity and d. It is given here, relation between velocity and d. This velocity is recorded by photo gate. Okay, so we have to draw a linear graph, and here d has been marked on x-axis. So this d has been marked on x-axis, and if you want to have linear graph, there should be v square on vertical axis. So vertical axis should represent v square, and its unit should be equal to velocity is meter per second, and its square, that is meter square second square. So its unit is meter square second square. So if you mention this, definitely you will get 1 point. Okay, so now I have to draw a graph. They have asked us to draw a graph, and we have to level it. So I have told you that on y-axis, we will plot v square. So d has been given, v has been given. So we have just squared v square, because on y-axis, we have to plot v square. So this is value of v square. And so now I have drawn a plot. Suppose when d was 0.2, then v square was 0.08. So this is 0.05, 0.06, 0.07, 0.08, and it is greater than 0.08, 0.084. So it will be somewhat between these 2 points. So similarly, I have plotted other point as well, and then I have drawn a graph. So you will get points on plotting these points, and also you will get points when you draw this best fitting line. So now, once again, see this expression. V square is equal to 2g sine theta minus mu k cos theta into d. And we know this sine theta, this angle of inclination theta has been given to be 30 degree. So this is v square and this is x. So this will be slope. So slope of line is twice g sine theta minus mu k cos theta. So this represents straight line passing through origin. This is plotted on x-axis and this has been plotted on y-axis. So this is slope. Let slope be equal to tan phi. So tan phi is given to be 2g sine theta minus mu k cos theta. And I have told you theta is 30 degree. So sine 30 is 1 by 2, cos 30 is root 3 by 2. So we have to calculate tan phi with the help of this straight line. So if this angle is phi, then tan phi will be equal to this length. This length is 0.25, 0.26, 0.27. So this is 0.27 divided by 0.6. So tan phi is 0.27 divided by 0.6. And then I have calculated it, and mu k nearly comes out to be 0.55.